All right, it's Thursday night. It's been a while. Here's an update on the GPS oscillator. Um, when we last left off, I was going to take the original design and do what would be more like the final layout to actually fabricate, and that's what I have done here. The things you'll notice that are different here, the control panel is sort of mixed in with the Arduino and some of the circuitry. Here, the control panel is its own separable, independent thing, linked only by this ribbon cable, because the idea there was this is the actual control panel that'll be in the box. The other thing I did is that the functional units are, here's the phase comparator, here's the counter, here's the high frequency stuff laid out a lot better. GPS is not over there, and I added the joystick fancy control for setting the frequency synthesizer, and I added some inductive filtering on the control voltage into the oscillator. And I did this layout, and not happy with a bunch of things. One of them is I was going to use these proto boards, and there's one for here, one for there. But then when you put it in the box, I'm not well. This is two separate boards, and so do you attach them together? Do you stack them on top? What do you do? And the box I have isn't very big, and so I didn't want to have a huge box to accommodate this proto board. So I think is there a way to do it better? And went back to my old friend, the green board. This is a whole lot smaller, more compact, and I decided to do the layout on this. The other thing I didn't like is when I was thinking about the control panel, this joystick thing is kind of cool, left, right, up, down, and then set for the digits. But having this little stub sticking out of the front panel, this is more like a D-pad for a joystick. It's not really meant to be sticking out of a front panel, or it's too fiddly to have sticking out of a front panel. So I didn't like that, wanted to do something different. And so I went over to the Computer History Museum and saw a lot of good 60s and 70s big iron, and got inspired by the controls and the control panels on that. And so where do I start? Well, first off, this is the layout. This is how the layout's going to be for the for the soldered version. And so I have the Arduino. The oscillator will go here. There's lots of room to have its insulating material. I have the phase comparator, the counter. Phase comparator feeds to this I/O expander. The counter goes into here. That's going to be the line driver. GPS, it's far away. There's push buttons and switches for a duplicate control panel on this because I need to be able to test it as I'm building it, but all the front panel controls will be jumpered in to these headers, but I still need these to test it. And everything is pulled up active low, so you can have switches and still have the front panel switches when they're activated. And then I have to have a right angle deal here to have a programming header to be able to program software changes without opening up the box. So this is the board design, and I have worked up, of course, the paper layout of all the connections. This is all the solder bumps on the back. I have this all done in Illustrator. I have all the power and ground connections, then all the logic connections, and then I have a reversed version that's backwards for when I flip the board over for each one of these. And so this is how I'm gonna solder it up, kind of like how I did the Nixie clock. There's not as much solder traces on the board, so this should go fairly quickly. It's a Thursday, and maybe by Saturday I'll be done. Depends on how much I actually do tomorrow. on the front panel, this is the layout of the front panel. I have the display, I have the tuning of the of an oscillator, tuning of the synthesizer, power, and then I can control power on and off the 10 megahertz and the synth out. Coming out the back panel. On the back panel I have a GPS, 2 BNCs for the high frequency stuff, programming, and the power coming in. For the controls, what I liked for the up-down are these paddle switches, and so these this one it's momentary. So if you're setting up or setting down, this one, when you're setting the synthesizer, you can do a momentary set after you've entered it in, or it has a on position that's up if you want to, as you're entering the frequency, have it change in real time. And then the power and the manual automatic mode and the output enable are just a normal rocker switch. So it's going to have kind of a slick look with these paddles, semi-retro kind of PDP style, I guess if you want to call it that. So I'm looking forward to building this. Since I have the design of the front panel all done, and actually I finally got the switches in just now, I can just double check and do a sanity check to make sure that these switches are the appropriate size as designed from the spec sheets, and everything's going to work out okay. This is a 1-to-1 copy, and so I can hold up everything to this and make sure that it's going to work. Part of the sanity check. So these two pieces, it's a 2-week fab, and I have the case already. I just have to start soldering on this, which shouldn't take, like I said, it should take a day or two. Probably not going to be able to do too much tomorrow, but certainly on the weekend I'll make good progress. The performance of these two guys, when I had them running side by side, the clocks would just ever so slowly drift, and I could fine tune it so that they were fixed on top of each other. So they're both, even though they're asynchronous, they're both, running off the same clock in the sky. So I was happy with the performance. If there's any jitter effects, I would have seen it in those two relative clocks. And so in my, how good is this clock evaluation, if there was any jitter in the clocks, I would see them when I trigger off of another clock, because they're on different time bases, and that was fine, and I was happy with the performance. And I had a thermal shield around this, but I took it off because when I was building my schematics or my wiring diagrams, I need to be able to see all the connections. And so that this layout, I thought it was kind of a waste at first. It was kind of a bummer when I started to work on it, and I wasn't happy with the way I started working on this, and I wasn't happy with the way it was fitting or turning out. And so it sort of sat there for weeks, and then I just finally just ripped up everything, laid it out the way I really wanted to, and wired up everything, cut all new wires. And it turns out not to be as big of a task as I had originally thought. And it was more of a mental block of ripping up your design. And then once I made this, I'm glad I did, because I found, again, like I said, all the issues with the switch and some layout things. And again, going to the soldered board, it's going to be a better product. I was thinking about actually doing a schematic and having a board fabbed. That was maybe a little bit too much. Maybe as a follow-on, do that. But I think that the soldering it by hand, it'll be fine. And I was able to work on controlling the grounds, where the signals are, and so the high frequency return currents, based upon how I hook things up, I can control. So that's the current status. you glad I got back into it. It's probably been 6 or 7 weeks since I've worked on this, but I've been working on it pretty much um, nonstop the last week or so. There's probably 2 days for this, 2 days to draw the diagrams. A day to design the control panel, and then order the parts that I didn't have. So lots of progress. Maybe I'll have a video on the weekend, if not next week, showing the working soldered version, and then there'll be a follow-up once the front panel and the rear panel fabs come back and the thing's fully assembled and working. All right. Well, thanks for watching.